So air conditioning systems. Basically, when we talk about air conditioning systems, we are talking about thermal distribution systems. In other words, thermal energy or heat is being distributed or being taken from various parts of the conditioned space. So schematically, it may be shown as the figure shown in this slide. So as you can see in this slide, this is the air conditioning plant. So you know what are the basic components of air conditioning plant. If it is based on vapor compression refrigeration system, you will have a compressor, condenser, expansion valve, and the evaporator. And then there will be some medium. This can be air or water. So this would be a pump or a blower, and with the help of that you are supplying heat or you are taking heat from the conditioned space. And this conditioned space has some heat load which may be coming from outside or it is generated inside. So we are talking about this thermal distribution system, which is basically an air conditioning system. So this air conditioning system works as a heat sink. So something which takes away heat is heat sink in summer. So you are taking away heat from the conditioned space in summer. So this will be called a heat sink, and it will be a heat source, that is you are supplying heat into the space for winter air conditioning. And what will be the medium here? The medium of heat transfer which is used can be refrigerant itself or can be water. So if it is summer air conditioning, it will be chilled water, or it can be refrigerant also. Right. So DX coil, if it is a direct expansion coil, it can be the refrigerant itself. Or there is a new type of refrigeration system now becoming very popular in the market, and that is variable refrigerant flow systems. So even in that case, the refrigerant directly goes into the space. There can be multiple cooling coils or evaporator coils in that system. So in that case, the refrigerant is the medium for heat transfer. And in addition to taking heat or giving heat, there is another task also which is also becoming very important, or people are becoming more conscious about that, and that is to provide fresh air to maintain indoor air quality, IAQ, in the space. Now, air conditioning systems selection and classification. So how will you select an air conditioning system for your need? So it depends upon one, the capacity required, second, performance requirements, and spatial requirements. That is, you should be able to fit a given system in the restricted space that is available with you. Second is initial and running costs. Obviously, what is the, when you buy it, what is the cost, how much you have to spend, and while it is running, what is the electricity bill and maintenance costs you have to incur. So that is the one of the criteria of selection could be that. Third, required system reliability and flexibility. Okay, how much can you depend upon the system? Low maintenance required, less breakdown, etc. And flexibility in case your requirement changes, then whether that system will suit your requirement or not. Maintainability and architectural constraints. So these are the selection criteria. Then based on the fluid media used in the thermal distribution system, air conditioning systems can be classified as 1, all air systems, 2, all water systems, air water systems. So the media for heat transfer, yeah. So in previous slide, I said that this media can be water or air or refrigerant, right? So here I have written refrigerant or water, but it's also air which can work as a medium. So if only air is used, then it is all air. If only water is used, it is all water. And if it's a combination of air and water, then it is air water system. And there are package units available which are also becoming popular nowadays, or they have been popular for a while. It is unitary refrigerant based systems. So we'll discuss about these one by one. So first thing is all air conditioning systems. In that you can have single duct system, In again, the subcategory of that can be constant volume single zone systems, constant volume multi-zone systems, or variable volume systems. Then it can be dual duct system also. So single duct constant volume single zone system, the schematic of that is shown here. So you can see a conditioned space here, and there is a thermostat shown, and there is a humidistat shown. So humidistat is for measuring the humidity, the moisture content. So you are familiar with a thermostat, right? The air conditioner that you use at home, it has a thermostat. So you can set the temperature on the thermostat, and that governs the functioning of the system. If you set it at a particular temperature, for example, if you set it at 27 degrees Celsius temperature, then if it is a constant speed compressor type of system, the compressor will run continuously till till the room condition is room condition at that temperature is achieved. And once that temperature is achieved, it will keep the compressor off for some time till the temperature exceeds, let's say, 28 degrees Celsius. Then it again starts the compressor, right? So that's the function of a thermostat. So this thermostat, and then there could be provision for a humidistat also, which controls the humidity in the space. Now the given system shown here can cater to the winter air conditioning as well as summer air conditioning. So what you see here is this is the return air. That is the air that you take from the conditioned space. There is a blower which handles it, and some part of it is exhausted because you want to take some outdoor air. And then there will be mixing of these two streams. Now you want to cool and dehumidify it, then you'll be using cooling coil. Heating coil may not be used in summer. If it is for the most of the times it will be only for the winter air conditioning purpose. And then there is a supply fan, a humidifier. Again, if humidity in the space is less than what is required, then a humidifier will be used. You can use steam injection, or you can use water sprays, and then it goes into the air goes into the space. So humidifier also generally it will be used in winter air conditioning only when the conditions are like very dry. So basically, when we say single zone, what we mean is this can be a large space, but the load is comparatively uniform everywhere. And so the supply conditions are governed by a single thermostat and a single humidistat. So that's why it's called single zone. There are no multiple thermostats and humidistats, and the supply condition is also not different at different points. So there is a single supply condition at which it is supplied. Now here there is only one outlet shown, but here there can be a duct, internal duct also, and it may get distributed in the space from different points, right? So the internal uh, ducts are not shown here. Only one exit point is shown here, but that may not be the case if the space is large. So there is a single thermostat and humidistat for control of conditioned space, and this system is suitable for large areas with uniform load and small external heat load. For example, auditorium, departmental store, theater. So it's a large space, but comparatively the heat coming from outside is less, and the internal heat generation is high. For example, an auditorium, so many people are occupying that space, so they all are heat generators. So in that case, the internal heat generation is high, but the heat coming from outside is not very high. So such a system may be suitable for that kind of application. Now multi-zone system. Okay, when we say constant volume, what we mean is that the amount of air supplied remains same. If you are talking about your air conditioner split AC, you have an option of changing the fan speed. So you are changing the volume of the air which is being taken into the indoor unit, and which is again supplied back into the room. But here, when you say constant volume, this fan or blower is running at a constant speed, and there is no change in the amount of air supplied to the space, right? So that is constant volume. So earlier, the pumps or blowers with different speeds were not very common. So constant volume systems were more common. But of course, nowadays there is a lot of flexibility in the speed of the given uh, blowers and pumps, and in that case, you are able to vary the volume. But here we are talking about the constant volume systems. Now, when you say multi-zone, it means that there are multiple uh, species, and they all have their own individual thermostat. Okay, so here we are showing only thermostat, so you are only controlling the temperature, which is a more common thing, rather than having control on both, that is temperature as well as humidity. So normally in very common applications, it's only temperature which is controlled, and humidity is indirectly controlled, and that's common for cooling and dehumidification requirements. So you have multiple areas or zones, and they all have their own thermostat, and by which they can control the supply condition. Now here in this system, this is a multi-zone system. This here what you see is, this is the return air blower. Some part of air may be exhausted. Most part is recirculated. Larger percentage is recirculated. Here you are taking fresh air from outside. Then this is the cooling coil for summer air conditioning purpose. This can be the heating coil for winter air conditioning purpose. There may be a humidifier. You are not showing dehumidifier because the cooling coil itself works as a dehumidifier. When the temperature of the cooling media here is less than the dew point temperature of this air, you are able to condense the moisture, or you can keep the temperature low enough so that you are able to achieve a certain dew point, and you can remove the moisture from the air. So this is the supply air blower, and then it is supplied to individual spaces, but then before it is finally supplied into the given zone, there are reheat coils. So if the load on the room is less, then you can reheat that air. For example, this air is coming at 13 degrees Celsius. Now the room load is not high. Let's say this is a gymnasium, uh, uh, and in morning hours it may run at full capacity, but then in let's say noon period or afternoon period, for a few hours, the occupants are less and equipments are also not running. So in that case, you may not need air at such a low temperature to take the load, because the load has decreased. So what may be done is, you increase the temperature, let's say from 13 to 17 degrees Celsius, and then you supply it into this zone, because this doesn't need very low temperature at the given point of time. So this is the thermostat with the help of which you can govern the temperature in the zone. So if the load is less, this thermostat, which is set at a particular temperature, accordingly it will give a signal to this reheat coil, and the amount of heating may be zero, or can go as per the requirement. So you are again increasing the temperature of the cool air. Of course, you may find it a bit odd, because you are supplying cool air, and then you are again reheating it, right? So you don't very commonly see such a system, but for very precise control of multi-zone systems, this may be done, but it may be now not very popular, as we become more and more conscious about the use of energy. But here one can use waste heat also. So if you are using waste heat, then you are not wasting heat for heating. Of course, you are unnecessarily cooling it to a lower temperature, So that's one of the issues here. So large buildings with several zones with different cooling and heating requirements. So if it is, let's say, a big resort and there is a conference room, there is a gymnasium, there are other facilities. So everywhere at different point of time, the requirement of cooling may be different. So what may be done is that it is supplied at a constant volume at a fixed condition, but then as per the requirement of that zone, the temperature of air supplied may be changed, right? So that's what is a multi-zone system. So air is cooled and dehumidified to minimum temperature and humidity ratio as required by the zone with highest heat load. Okay, and then it will be reheated by reheat coil before the zone as required supply conditions for that zone activated by the zone thermostat, right? So this reheat coil is activated by the zone thermostat as per the requirement. Okay, and reheat coil can be electrical heater or hot water coil. Then this single duct constant volume multi-zone system, what are the advantages of that? It is the relatively space requirement is low, excellent temperature and humidity control over a wide range of zone loads, proper ventilation and air quality in each zone is maintained as the supply air amount is kept constant under all conditions. So when you are talking about constant volume systems, the amount of air which is handled by this and this blower is same. So you're always taking some outside air also, right? Some outside air also. So the amount of air supplied is not changing. So you're also ensuring some minimum amount of outdoor air in such systems. So that's a plus point about these systems, that proper ventilation and air quality in each zone is maintained as supply air amount is kept constant under all conditions. Disadvantages of these systems is, as mentioned earlier, high energy consumption for cooling, as the air is first cooled to a very low temperature and then heated in the reheat coils. Thus, energy is required first for cooling and then for reheating. The energy consumption can be partly reduced by increasing the supply air temperature such that at least one reheat coil can be switched off all the time. So you don't keep it at a very low temperature. You keep it at a temperature where you can satisfy the zone with the highest load. So there should not be any need of reheating. But then others which have low load may have a heating requirement with the help of the reheat coil. The energy consumption can also be reduced by using waste heat, such as heat rejected by the condensers of the air conditioning system in the reheat coil. Simultaneous cooling and heating is not possible. So this system is suitable. Like if you're talking about summer air conditioning, then this reheating may be used. If you're talking about winter air conditioning, then there is no use of this reheating coil, or it can be probably a cooling coil. At a given point of time, if one zone is to be heated and another zone is to be cooled, that won't be possible in such systems. Then a single duct variable air volume system. So here we were talking about the systems where the amount of air supplied to each zone is remaining constant. It may be different in different zones, but for a given zone it is constant. But now you are putting a damper here, with the help of which you can control the amount of air coming into the zone. Okay, and that damper position, that is the amount of air coming in the given zone, is controlled by the room thermostat. So you can see this connection. So it can be open or close. It's like a valve for water or liquid. For air, it is a damper. So with the help of that damper, you can reduce or increase the amount of air that is coming in a given zone. So accordingly, this blower may have to handle higher amount of air or lower amount of air as per the requirement of different zones. So it is variable air volume. Now, why do you want to control the amount of air? You are supplying the air at a particular condition. Now, if the load on a given space is less, you will supply less amount of air, and if the load is high, you will supply more amount of air. Okay, so that's how the amount of cooling provided is changed as per the requirement. You are not using a reheat coil, right, and not increasing the temperature if the load is less. What you will do is you will reduce the amount of air coming. You will close the damper partially, so that amount of air is coming is low, and then MCP delta T. So if mass of air is decreasing, the amount of cooling provided also will decrease. So that's the strategy which is used in this system, variable air volume systems. So air is cooled and dehumidified to a particular condition and supplied to each zone. The zone thermostat controls the amount of air by operating the damper. Lower amount of air is supplied when the heat load on a given zone is small. Compared to constant volume systems, the variable air volume system offer advantages such as lower energy consumption in the cooling system, as air is not cooled to a very low temperatures and then reheated as in constant volume systems, right? So there is no reheater here, so you are not unnecessarily cooling for a particular zone to a very low temperature and then reheating in other zones. So that strategy is no more there. So because of that, you are not unnecessarily cooling it to a very low temperature. So that's one way you are saving the energy. Second is lower energy consumption also results due to lower fan power input due to lower flow rate. When the load is low, let's say the load on one or two zones is less, so they will consume less amount of air. So you can run the blower at a lower speed, reduce the total amount of volume of air handled. So that will also decrease the fan power. These systems lead to significantly lower power consumption, especially in perimeter zones where variations in solar load and outside temperature allows for reduced airflow rates. Perimeter zones are, if you are talking about a very big building, the buildings which are on the perimeter, okay, outer periphery, or the zones or the spaces which are near the perimeter of that building, right? So those are called perimeter zones. So there will be some wall in those zones which will be exposed to the sun, right? Inner core areas may not be exposed to the sun directly, but the perimeter zones can be exposed to the sun directly. So what will happen is, if there is some zone on the east side, so the wall of that zone may be exposed to the sun, but only in the morning. So in morning it will have higher load, but in the afternoon it may have lower load, right? So when the load is lower at that time, you may supply less amount of conditioned air to that zone, right? So these systems lead to significantly lower power consumption, especially in perimeter zones where variations in solar load and outside temperature allows for reduced airflow rates. However, since the flow rate is controlled, there could be problems with ventilation, indoor air quality, and room air distribution when the zone loads are very low. In addition, it is difficult to control humidity precisely using variable air volume systems. Balancing of dampers could be difficult if the airflow rate varies widely. However, by combining variable air volume systems with terminal reheat, it is possible to maintain the airflow rate at a minimum required level to ensure proper ventilation and room distribution. Okay. So the problem with these systems is, let's say there is a very low load in a particular zone. Let's say in zone 2, the load is very low. Like the capacity of this theater is, let's say, 200, but then at some point of time there are only 20 people sitting, so the load is less. So what will happen is, you will supply very low amount of air, but then what happens is, when the amount of air is low, the distribution is also difficult, right? Proper distribution is also difficult. right? So that is one of the difficulties. Second, when the amount of air is low, at that time the amount of fresh air supplied is also low, so amount of ventilation is also low. So that may be a bit of a problem in these type of systems. But then what may be done is that you decide some minimum amount of air, that is, even if the load is low, you will still supply some minimum amount of air so that the distribution and ventilation is there, proper distribution and ventilation is ensured. But in that case, you may have to put a reheat coil here, so as to increase the temperature of the air slightly, right? So it may be combined. The reheat coil may be combined with the variable air volume system. Now the next one, the dual duct constant air volume system. So in all earlier systems, there was only one duct. It carried either cooled air or heated air or warm air, right? But here you are talking about two different sets of ducts. One duct carrying uh, cold air and another duct carrying warm air or heated air, right? Now what is done here is this part is same, that is the outside air is taken, the air is exhausted, the recirculated air, and then this blower is there. Then there are two parts. One part where the cold air is, one duct where the cold air is carried, another duct where hot air or warm air is carried. Now it's not that only in winter this heating coil will be used and it will heat the room. No, even in summer you will still have some warm air. Now what is done is, for example, in summer the zone 1 at a particular point of time has very high heat load. So in that case, what you may do is you supply only cold air. You take it from here and you supply it into zone 1 and you don't take any hot air. But then at that point of time, zone 2, the heat load is very less. So what you will do is the amount of air is still same. The air supplied here is still same, but you will change the proportion of cold air and hot air. So if the load here is less, what you'll do is you will take some amount of this cold air and you will mix some hot air or warm air with that, create some intermediate temperature, and then supply it to zone 2. So that's the strategy used in the dual duct system, but the amount of air supplied to a given zone is still the same. So cold air supply, cold air in this duct would be somewhere around 13 degrees Celsius most of the times. Warm air is in the range of 35 to 45. Cold and warm air are mixed in required proportion, okay, to produce a required temperature, and that will be controlled by the room thermostat, the zone thermostat. So you can see that thermostat, it gives a signal to this. There would be two dampers here, one for the cold air, another for the warm air, and it will change the proportion in which these are mixed so that you are ensuring a particular temperature for the given zone as per the load on that zone. Supply air quantities remain same, but temperature varies as per the load and that load on that zone. This is about the dual duct system. Advantages of dual duct systems: since total airflow rate to each zone is constant, it is possible to maintain proper indoor air quality and room air distribution, right? The airflow rates remain same, so the issues with very less airflow rate are not pertinent here. Cooling in some zones and heating in other zones can be achieved simultaneously. So that is one of the distinct advantage. So what may be done is, let's say zone 2 has a heating requirement, zone 1 has a cooling requirement, and zone 2 has a heating requirement. Now these things may occur in a very big complex. So in some zones, even if let's say it is winter, some zones have very high internal heat generation. So there may be need for cooling in one zone and heating in another zone if it is winter. But internal heat generation in winter is high, let's say in zone 2. So there may be cooling requirement in that zone. So this will be possible what may be done is, if there is a heating requirement, you just stop the flow of the cold air and you supply only hot air, and the opposite thing may be done in another zone. So heating and cooling simultaneously can be achieved. System is very responsive to variations in zone load, thus it is possible to maintain required conditions precisely. Disadvantage is occupies, now you have two sets of ducts, so obviously occupies more space, as both cold air and hot air duct have to be sized. Again, there is a mixing chamber and to handle all the air flow rate if required. Not very energy efficient, because you are producing hot air on one side and cold air on another side, and to reduce the temperature you are mixing them. To need for simultaneous cooling and heating of all of the air streams. However, energy efficiency can be improved by completely shutting down the cooling coil when the outside temperature is low and mixing supply air from fan with hot air in the mixing box. So this is somewhat advanced concepts. So if the outside air is at a low temperature, and so in that case you don't recirculate the air, but you take the outside air for cooling purpose. Right. Similarly, when the outside weather is hot, the heating coil may be completely shut down. Right. So you take the outside air for heating purpose. So that's possible, and you can save energy in such cases. Advantages of all air systems in general, because now we are going to talk about all water systems. So before that, we talk about the advantages of all air systems. So they have greatest potential for energy conservation by utilizing outdoor air effectively. Okay, so according if you take the advantage of the temperature, low temperature of outdoor air for cooling purpose, or if it is heating requirement and outdoor air is hot, you take the advantage of that, then you can save energy. By using high quality controls, it is possible to maintain temperature and relative humidity precisely. Using dual duct systems, it is possible to provide simultaneous cooling and heating. It is possible to provide good room air distribution and ventilation under all conditions of load. Building pressurization can be achieved easily. In some cases, there may be need for pressurization of the space. In the given space, you may want that the pressure is bit higher, so that if there is means the air leaks outside, you don't want any outside air to come in. So in that case, the space conditioned space may be pressurized a bit. It's not a very high pressurization, just a few millimeters of water column, and it may be the opposite. That is, you don't want any space, you don't want any air from that space to go outside. For example, in this COVID conditions, the ICU where such patients are kept, you don't want the air from that space to leak outside. So it may be kept at a slightly negative pressure, so that there is no leakage from that space to outside. If there is a leakage, the outside air is coming into that room. Then the complete air conditioning plant, including the supply and return air fans, can be located away from the conditioned space. Due to this, it is possible to use a wide variety of air filters and avoid noise in the conditioned space. Right. So all air conditioning equipment is away. Right. You know, part of that is inside the space. It's only the duct opening. So that may be an advantage in many cases. Disadvantages of such systems is that you are carrying air. So air has high specific volume and low specific heat. So you want more volume. You need to handle more volume. So that will occupy more space and reduce available floor space in the buildings. It could be difficult to provide air conditioning in high-rise buildings with the plant on the ground floor or basement due to space constraints. Right, high-rise building, multiple floors are there, all need the conditioned air. So your duct has to run through all the floors. So all the duct is when you say duct, it's not a very small thing like a pipe. right? So there may be some space constraints. So retrofitting may not always be possible due to space requirement. Retrofitting means you want to modify something at a later stage, so it may not be very easy. Balancing of air in large and particularly with variable air volume systems could be difficult, right? So you want to change the amount of air in different spaces at different point of time, and the need may be changing continuously. It's a dynamic situation, so the balancing may not be that easy. All air systems can be used in both comfort as well as industrial air conditioning applications. They are especially suited to buildings that require individual control of multiple zones, such as office buildings, classrooms, laboratories, hospitals, hotels, ships, etc. They are also used extensively in applications that require very close control of conditions in the conditioned space, such as clean rooms. Clean rooms are related with pharma industries, where the particular matter concentration has to be very low. Computer rooms, operation theaters, research facilities, etc. So let's talk about all water air conditioning systems now. Here water is used as the thermal transport media, and there can be two pipe system or four pipe system, right? So in case of this is like single duct and dual duct systems, right? So two pipe means there is only one supply pipe, one return pipe, so two pipe system. Four pipes means two supply pipes, one carrying hot water and one another carrying cold water or chilled water, and again return cold water and hot water, right? So that will be four pipe. Here only two pipe system is shown. The quantity of supply water depends on load on the zone, and separate arrangement for fresh air is required here, because this is the air conditioning system is not handling the air, right? So there has to be separate provision for the fresh air. So here there is a central heating or cooling. It can be water chilling plant or water heating plant. If it is a heating plant, there can be a boiler with the help of which you are achieving hot water. But the common application, summer air conditioning, it will be a refrigeration plant which produces chilled water. It will be pumped into the system. There can be multiple zones, and each zone may have requirement of different cooling load or heat load. So accordingly, this is the thermostat in that zone, and it will take more or less amount of water which will pass through this coil. There will be a fan coil unit which will be shown in the next slide, and amount of water may be increased or decreased according to the requirement of that zone, heat load on that zone. And this is the return air pipe, and then it goes back into the cooling coil. So this is a two pipe system, one supply pipe of water, another return pipe, return water line. Okay, and this will be distributed into multiple zones. Okay, and this is pressure relief valve. So inside the room, this thing will be there, the fan coil unit. What is shown here? Okay, this one is shown in the next figure. So here, this is the fan coil unit. Cooling rate can be controlled by varying water flow rate or air flow rate or combination of that. So even in a given space, this is the connection of the chilled water, cold water. So one is supply, another is it's coming out from the coil. Coil, you know, it's the heat exchanger, and you will pass air over that. So you can see at the bottom, warm air from conditioned space, it is filtered. This is the fan which is taking that air, sucking the air. It is passed over this coil and then supplied back. This is something like indoor unit of a split AC. But it can be chilled water coil also here in place of the direct expansion coil. Heat transfer can be by convection and or radiation. So if you expose this coil to the room, then there can be heat transfer by mode of radiation also. Radiation is more common when you want to heat the room than in case of cooling. Of course, there is a different concept altogether of radiant cooling systems, which is not discussed here. Advantages of all water systems: the thermal distribution system requires very less space compared to all air systems. Thus, there is no penalty in terms of conditions, floor space. Also, the plant size will be small due to absence of large supply air fans. Okay, so here you are using pumps and pipes in place of ducts and fans. That's an advantage. Individual room control is possible. At the same time, the system offers all the benefits of large central system. So individual room control is possible. You're changing the amount of water supplied, and this offers the benefits of large central systems. So lower capital cost and generally lower running costs. These are the advantages of large central systems. Since the temperature of hot water required for space heating is small, it is possible to use solar or waste heat for winter heating. It can be used for new as well as existing buildings retrofitting, because the pipes sizes are small, the diameter is small, and pump size is small. You can use a building which is non-air conditioned. You may change it to conditioned building. So retrofitting is possible if you use all water system. Simultaneous cooling and heating is also possible with 4 pipe systems. And the disadvantage and applications of all water systems require higher maintenance compared to all air systems, particularly in the conditioned space. So that fan-coil unit could be one issue. Draining of condensate water. In fan-coil unit, there is a drain pipe, right? And that may be messy, may create health problems if water stagnates in the drain tray. This problem can be eliminated if dehumidification is provided by central ventilation system, and cooling coil is used only for sensible cooling. Okay. So dehumidification. So in that case, you need a separate air system for dehumidified air, and only sensible cooling is done in the room. If ventilation is provided by opening windows or wall apertures, then it is difficult to ensure positive ventilation under all circumstances, such as this depends on wind and stack effects, right? Control of humidity, particularly during summer, is difficult using chilled water control valves. All water systems using fan coil units are most suitable in buildings requiring individual room control, such as hotels, apartment buildings, and office buildings. There could be air water systems also, where there is a combination of the chilled water or low temperature water supplied to a particular zone, as well as there is an air also supplied. So as mentioned in the previous slide, like you may use this water only for sensible cooling, but dehumidification requirement may be met with this primary air duct here, primary air, which is dehumidified here, and then you are supplying dehumidified air into the space. But in addition to this primary air which is coming from the central plant, the room air is also you need some minimum amount of air for increasing the convection. So you, in addition to that, you may also handle the air from the room or the zone itself, which is called secondary air. These buildings are mainly used in exterior buildings with large sensible loads. Exterior buildings means the spaces which are exposed to sun directly. So because of the exposure to sun, they may have large sensible load, right? The sun is only imparting sensible load. It's not giving any moisture to the space. So it may have large sensible loads due to sun. Where close control of humidity in conditioned space is not required, these systems are thus suitable for office building, hospitals, schools, hotels, apartments, etc. So that was about the air conditioning systems. Now unitary air conditioning systems. So these are actually the package units, the factory assembled units, and the very common things that you see around you, the window ACs and split AC fall under these categories. And there is also one variety called ductable split AC, which is a bit bigger in size. The split AC that you use at home or in small facilities, that is not ductable. So the outlet of the indoor unit or the cooling unit, you cannot connect a duct with that. But ductable split ACs have a provision as shown here. You can connect a duct with that, and you can carry that duct to some distance, and you can even distribute it in the given space. right? So the schematic of that is shown. This is the chilled water producing unit, or it can also be refrigerant. It may be this may be the direct expansion coil also. So this may be the low temperature refrigerant going into this system and coming out, and you are taking the air from the conditioned space, filtering it, and you are reducing the temperature and humidity, and then with this you are carrying it to the different points in the space and distributing it there. So ductable split ACs, you can even go up to 100 tons of refrigeration systems, which are these are the factory assembled units, not prepared at site or assembled at site. So unitary AC systems, the advantages is individual room control is simple and inexpensive. Each conditioned space has individual air distribution with simple adjustment by occupants. Performance of the system is guaranteed by manufacturer. System installation is simple and takes very less time. Operation of the system is simple and there is no need for trained operator. Initial cost is normally low compared to central systems. Retrofitting is easy as the required floor space is small. So this 6 point may be correct for some intermediate sizes, not for a very large size. And then unitary AC system disadvantages: as the components are selected and matched by the manufacturer, the system is less flexible. Power consumption per ton of refrigeration can be higher. Close control of space humidity is difficult. Noise level in the conditioned space could be higher. Limited ventilation capabilities. Systems are generally designed to meet appliance standards rather than the building standards. May not be appealing aesthetically. The space temperature may experience a swing on off control is used in the room air conditioners. Limited options for controlling room air distribution. Equipment life is relatively short. Okay, so this is about the unitary air conditioning systems, the disadvantage of that. Right, so we have talked about different types of air conditioning systems in this lecture.